Hello friends and dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is part 15 video on the chapter of probability, where I will be solving 5 multiple choice questions based on the concept of possible outcomes and favorable cases that I discussed in part 12, 13 and 14. This video is part of the playlist CBSE Maths for class 9 following the textbook of author R.T. Sharma. If you like this, if you find this video beneficial, then please like it, share it with your friends, and if you want to further support me, then please subscribe to my channel, and in that case, do not forget to press the bell icon so that you will be notified by my future videos. So let's start part 15 video, where I will be solving 5 MCQ on the concept of possible outcomes and favorable cases that was discussed in part 12, 13 and 14. Okay, the first problem says a card is drawn at random from a well shuffled deck of 52 cards. The probability that the card drawn is neither a red card nor a queen. Neither a red card nor a queen. Okay. Now, sometimes, okay, okay. So, let's say, so how many possibilities are there if of drawing a card from a deck of 52 cards? Quite obviously, the n, that is the number of tries. Most of the problems are the probability of an event are based on empirical formula. That is, the probability of an event, the probability of any event is equal to small m by small n, where small m is the number of cases or number of trials favorable to the event T, and small n is the total number of trials. In this problem, it is always very important that you are able to relate the concept of the total number of trials, all the possible outcomes. If total number of trials are not given, then possible outcomes are basically the total number of trials. And to understand an event and what are the outcomes from the possible outcomes which are favorable to an event E. Okay. So in what is small n, the total number of trials for this for this experiment is nothing but the total number of cards in the deck, which is 52. Now let's say if I define the event E, that a card drawn is neither red nor a queen. Okay. So what are the number of favorable cases for this event? So a card cannot be a red. The event says that a card drawn is neither red nor queen. So it can be any black. It can be a black, or it can be a black, or but it can be black, but it cannot be a queen. Okay. So what are so how many black cards are there? Number of black cards. We know in a standard deck of 52 cards, the number of black cards is equal to 13 multiplied by 2, because the black cards, the two suits that are black are spade and clubs, and each suit has 13 cards. So for all the cards in the suit of spade and clubs is 13 into 2, that is 26 black cards are there. So we can choose a black card, but the event E also says that it cannot be a queen. So how many queens are there? In each suit there are 2 queens. In each suit there is 1 queen. So out of these 22 cards, there are 2 queens. one queen from the spade and one queen from the clubs. So I can say that small m for the event E will be 26 minus 2, which is 24. 26 is the total number of black cards, and but in this out of these 22 black cards there are 2 queens, so we have to exclude those 2 queens. So 26 minus 2, 24 is the total number of cards that is favorable to the event, which says, and the event is a card drawn is neither red nor queen. So now clearly we can say that the probability of the event E will be small m by n, which is 24 by 52, which of the cancellation is 8 by 13. 8 by 13, and it is not there in the choice. Sorry, it is not 8 by 13, it will be 6 by 13. So 6 by 13 is the probability that a card drawn randomly from a well-shuffled deck of 52 cards will be is neither a red or nor a queen. Okay, let's see the next problem. Question 2 says, 2 dice are thrown simultaneously. The probability of getting a multiple of 2 on one die and a multiple of 3 on the other die is. So 2 dice are thrown simultaneously. We know that what are the possible outcomes of this random experiment. PO denotes, I denote PO by the possible outcomes of a random experiment as a set. So if I denote outcome, if I represent an outcome by the numbers showing up on the 2 dice separated by a dash. So what are the possible outcomes? If 1 comes on the first die, and then let's say 1 comes on the first die, and we can have 6 possibilities of 6 possible numbers that can show up in the second die. So 1, 1-2, 1-3, 1-4, 1-5, 1-6. This way, let's say we can have 2 showing up in the first die. We can have 2, 1, 2, 2. This way, we have 2, 6. This way, we have up to 6, 1, 6, 2. Like this, we have 6, 6. So basically, what is small n? The total number of outcomes when 2 dice are thrown. It is 6 multiplied by 6, that is 36. Why 6 multiplied by 6? Because there are 6 possibilities. The number that can show up in the first die has 6 possibilities. It can be any number from 1 to 6. Similarly, for the second die also there are 6 possibilities, 1 to 6. So for each possibility of the first die, there are 6 possible numbers that can show up in the second die. So and hence for 6 possibilities of the first die, there are 6 possibilities of the second die. So it is 6 into 6, 36 is the total number of possible outcome. Okay, now what is the event? The question has asked to find the probability of getting a multiple of 2 on one die and a multiple of 3 on the other die. Now there is a little trick. There is the one thing you have to understand, that the problem is the question is not saying that of getting a multiple of 2 on the first die and a multiple of 3 on the second die. It is not saying that. I mean, so the first die can show so all the outcomes, okay. So if I consider E to be the event getting a multiple of 2 on one die. Let's say I define two other events. Event E1 I am defining as getting a multiple of 2 on the first die. On first die, and event E2, let's say I'm getting a multiple, no, even let's say even the event E1B getting a multiple of 2 on the first die and a multiple of 3 on second die. I am defining this event because we have to consider all those outcomes where the first die, the number on the first die is a multiple of 2 and the number on the second die is a multiple of 3. It could also be that the number on the first die is a multiple of 3 and the number on the second die is a multiple of 2. We have to consider both the cases. So that is why I am trying to define more events so that the main event whose probability has been asked in the question, we can define that event using some other simpler events. So those I will define two. I am defining two events, E1 and E2. E1 is that getting a multiple of 2 on first die and a multiple of 3 on second die. I am defining E2 same, but getting a multiple of 2 on second die and a multiple of 3 on first die. So event E1 is that the first die will show a number which is a multiple of 2 and the second die will show a number which is multiple of 3. And the event E2 is the first die will show a number multiple of 3 and the second die will show a number multiple of 2. Then the event E, if I consider event E to be the getting a multiple of 2, let's say event E be the event whose probability has been asked in the problem, that is getting a multiple of 2 on one die and multiple of 3 on other die. This is we have to find the probability of this event E. Now please note that the event E is nothing but the occurrence of event E1 or event E2. So event E is E1 or E2. Event E1 is that a multiple of 2 will occur in the first die and a multiple of 3 will occur in the second die, and the event E2 is the other way around, the multiple of 3 on the first die and multiple of 2 on the second die. So the event whose probability has been asked, that is getting a multiple of 2 on one die, it is not mentioning which die, and multiple of 3 on the other die will be E1 or E2. So then the probability of event E will be equal to the sum of the probability of event E1 and event E2. Now let's find out what are the favorable cases. What are the favorable cases of the event E1? That is, we have a number which is a multiple of 2 on the first die and a number multiple of 3 on the second die. So a multiple of 2 can be 2, 4 and 6, and multiple of 3 can be 3 and 6. So for the event E1, I can choose for the die 1, I can choose any number from 2, 4, 6. So the possible outcomes for event E1 will be 2, 3, 2, 6, and then 4, 3, 4, 6, and then 6, 3, and 6, 6. These are the possible outcomes of event E1. So, M for the event E1 is 1, 2, 3, 4, 5, 6. 6. There are 6 outcomes which is favorable to the event E1. Let's see for event E2, it will be the other way around. Basically, it is nothing but I can say it will be the numbers on the die will be get reversed. That is, it will be 3, 2, 6, 2, 3, 2, 6, 2, then 3, 4, 6, 4, and 3, 6, and 6, 6, 6, 6. But okay, now see that in both the events E1 and E2 we are having 6, 6. We are having 6, 6. Okay, so for event E2, what is M? M is 1, 2, it will be same 6, but what is the number of favorable cases to the event E? It will be the number of the sum of the number of favorable cases to E1 and the number of favorable cases to event E2. But please note that in both the event E1 and E2 we are having 6, 6. So it is occurring 2 times. So we have to exclude 1 time. So then for E, so what will be the number of favorable cases to the event E? It will not be 6 plus 6. It will be 6 plus 6, but we have to exclude 1 time for 6 and 6, because if we do 6 plus 6, then we are considering the outcome 6, 6 2 times. So minus 1. This is 11. This is 11. So 11 is the number of 11 is the total number of 11 is the number of favorable cases to the event that of getting a multiple of 2 on one die and multiple of 3 on the other die. So 11 by 36 should be the 11 by 36 should be so probability of E will be 11 by 36. It was a little tricky, but the only thing let me once again discuss how I solved the problem. So I first listed down all the possible outcomes of the experiment. Obviously, it will be there are 36 possible outcomes: 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, like these 2, 1, 2, 2 up to 2, 6, and then 6, 1, 6, 2 up to 6, 6. There are 36 possible outcomes when 2 dice are thrown at the same time. I defined 2. The question is asked to find the probability of getting a multiple of 2 on one die and a multiple of 3 on the other die. It has not mentioned whether the multiple of 2 will be in which die. So we have to consider both the cases. The first case, we will get a multiple of 2 on the first die and the multiple of 3 on the second die. And in the other case, we will have a multiple of 3 on the first die and a multiple of 2 on the second die. So these 2 cases I have defined as 2 events, E1 and E2. Event E1, I am saying getting a multiple of 2 on first die and a multiple of 3 on the second die. And event E2 is the same thing but the other way around, that is getting a multiple of 3 on the first die and multiple of 2 on the second die. Now, so obviously then the event E whose probability has been asked, that is the event E getting a multiple of 2 on one die and multiple of 3 on the other die, is equivalent to saying occurrence of event E1 or E2. So E1 or E2, and then the probability of E will be equal to probability of E1 plus probability of E2. But but there is a catch. We have to be careful. As you can see, the favorable cases for event E1 are 2326, 43, 46, 63, 66, and the favorable and the outcomes which are favorable to the event E2 are 32, 62, 34, 64, 36, 66. But so the number of cases which are favorable to either E1 or E2 will be equal to 6 plus 6, but it will not be 6 plus 6. We have to be careful, because if you do 6 plus 6, then we are counting the outcome 6 6 twice, so we have to deduct once. So that is the reason I am doing 6 plus 6 minus 1, that is 11. 11 is the number of outcomes which is favorable to the event E, which is getting a multiple of 2 on one die and multiple of 3 on the other die. I hope I was able to properly explain how this problem was solved. So then the probability of event E will be 11 by 36. Okay, let's see the next problem. So the correct choice is C. C is the correct choice. And for the question number 1, the correct choice was A. A was the correct choice. Let's see question number 3. Two dice were thrown simultaneously. Find the probability that the sum of the numbers on them was a 2-digit prime number. Okay, so what are the 2-digit prime numbers? The 2-digit prime numbers are 11, 13, like this. But we know that the sum of the numbers when two dice are thrown, the sum of the numbers can be maximum 12, that is 6 plus 6, 12. Okay, so we know that the possible outcomes when two dice are thrown at the same time are something like this: 1 1, 1 2, like this, 1 6, and then 2 1, 2 2, 2 6, and then like this, 6 1, 6 2, 6 6. Okay, now okay, so how many possibilities, how many possible outcomes are there of this experiment? That is, when we throw two dice simultaneously, how many possible outcomes are there? It is 6 multiplied by 6, which is 36. Now we have to find out of these 36 possible outcomes, how many of these outcomes are favorable to the event that the sum of the numbers on the two die is a 2-digit prime numbers. Now 2-digit prime numbers can be only 11, because the sum of the numbers when two dice are thrown, the sum of the numbers showing on them can be a maximum of 12, and so the two-digit prime number less than 12 is only 11. So we have to then find all the outcomes where the sum of the numbers on the two dice is equal to 11. So what can those outcomes be? So if I consider E to be the event sum of numbers is 11. In the problem it is saying that the sum of the numbers on them is a 2-digit prime number, and for this experiment that 2-digit prime number can only be 11, because the maximum the value of the value of the sum of the numbers showing up at the two die is maximum 12. So the 2-digit prime number less than 12 is only 11. So the event is sum of numbers is 11. So what are the favorable cases of this event in this experiment? We can have So what numbers we can have on the two die so that their sum is 11? I think there are only two. The number on the first die can be 5 and the other can be 6. And the number on the first die can be 6 and the other can be 5. So two possibilities. So m, small m, that is the number of possible outcomes which is favorable to the event, is 2. Hence, probability of the event E is m by n, which is 2 by 36, which is 1 by 18. 1 by 18 is the probability. So the correct choice is B. B is the correct choice. Let's see the next problem. 3 unbiased dice are rolled, then find the probability that the sum of the numbers showing up is divisible by 9. Okay. If 3 unbiased dice are rolled, then find the probability that the sum of the numbers showing up is divisible by 9. Okay. Three dice are rolled. So we are having 3 numbers showing up on each die. So first of all, what will be small n? Small n will be 6, because there are, on the first die, there are 6 possibilities of numbers showing up. It could be any number from 1 to 6. Also, the second die will have 6 possibilities and the third die will have 6 possibilities. So the total number of possibilities, possible outcomes of this experiment is 216, is 216. 36 multiplied by 6 is 216. Okay. Now, out of these possible outcomes, how many outcomes are favorable to the event that the sum of the numbers will be divisible by 9? Okay. So let's see. Let's find out. Let's try to find the combination of 3 numbers whose sum is equal to is divisible by 9. Okay. Now, definitely, what is the okay? So when the sum of the numbers showing up in the so when 3 dice are rolled, what is the minimum value and the maximum value of the sum of the numbers showing up on the die? The minimum value will be 3, because if all the dice or if all the die are showing up 1, then the sum will be minimum. So it is 3, and the maximum can be 18. So when 3 dice are rolled, the sum of the numbers showing up can range from 3 to 18. Okay. Now let's so how many numbers are there between 3 to 18 which are divisible by 9? There are only 2 numbers which are 9 and 18. Between 3 and 18, how many integers are there which are divisible by 9? There are 2 numbers, 9 and 18. So now we have to find all those possible outcomes where the sum of the numbers on the 3 dice are either 9 or 18. Okay. So if E be the event, sum of numbers is divisible by 9, whose probability we have to find. Let's try to find what are the favorable, what are the outcomes which are favorable to the decedent E. So we have three die. Okay. So one possible outcome is that the number 6 is showing up on all the three die. 6, 6, 6. So this is the case where the sum is 18. Now there are no other ways, there are no other combination where the sum will be 18, because 18 is the maximum, and 18 is the maximum value of the sum of the numbers showing up in the three die. Now how can we, so let's see, now let's try to figure out all the possible outcomes when the sum of the numbers on the die showing up on the die is equal to 9. There are many possibilities. Now you have to be very patient and list down all the possibilities. Let's say if there is one showing up on the first die, then the second die and the third die, their sum, the numbers showing up on the second die and the third die should be equal to 8. Should be equal to 8. So we can have 2, 6. Also, we can have 6, 2. We can also have 3, 5, and we can have 5, 3. So these are, so this is the possibility, this is the outcome where the sum is 18, and these are the combination 126, 162, 135 and 153. These are the combination or the outcomes where the sum of the numbers showing up in the three die is 9. Let me see if there are any other outcomes. Obviously there will be, because this was the case when I assumed that the number 1 is showing up in the first die. We can also have the number 2 showing up in the second die. In the first die, if number 2 shows up on the first die, then the sum of the numbers showing up in the second and third die should be equal to 7. And that can have, so how many possibilities are there? How many outcomes are there? We can have 1, 6. We can have 6, 1. We can have 2, 5. We can have 5, 2. We can have 3, 4. We can have 4, 3. Okay. So if so these are so when okay. So when the number showing up on the first die is 2, then these are all the possibilities, so that the sum of the numbers showing up in all the three die is equal to 9. This way we can also consider the number showing up on the first die to be 3. Five, 3. Then the sum of the numbers showing up on the second and third die has to be equal to 6. So that can happen. We can consider 1, 5. So this seems to be a very lengthy way of doing. I don't know whether any other smarter way of solving this problem, but anyway, since I have already started, let's complete all the possible outcomes. So this can be 5, 1. This can be 2, 4, 4, 2, and this can be 3, 3, 3. Okay. Let's see. What if number 4 shows up on the first die, then the sum of the numbers showing up on the second and third die has to be equal to 5. So that can happen 1 4, 4 1, 2 3, 3 2. Yes, only this one. Okay. What if number 5 shows up on the first die? Then the sum of the numbers showing up on the second and third die has to be equal to 4. Has to be equal to 4. So we can have 1 3, 5 3 1, 5 2 2. These are the only possibilities. Okay. We can also have number 6 on the first die. Then the sum of the numbers showing up on the second and third die has to be 3, which can happen 1 2 and 2 1. And finally, if now okay, so these are all the possibilities. Since there are only 6 numbers that can show up in a die, so these are, I think I have covered all the possible outcomes where the sum of the numbers showing up on the 3 die is either equal to 9 or 18. So how many outcomes are there? 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25. So M is 25. So then the probability of the event E will be equal to M by N, which is 25 by 36. 25 by not 36 but 216, because N is 216. Total number of outcomes when 3 dice are rolled at the same time is 216. So 25 by 216 should be the answer, and it is not matching. Okay. Okay. So I might have done some mistake. So the minimum, the sum, okay. The sum of the numbers showing up in the 3 dice can have a minimum value of 3 and it can have a maximum value of 18. Okay. So between 3 and 18, the numbers which are divisible by 9 are only 9 and 18. Is divisible by 9. Okay. So it should be 9 and 18. So we have to then find all the possible outcomes where the sum of the numbers showing up in the 3 die is either 9 or 18. So 666 is the only combination where is the only outcome where the sum is equal to the sum of the numbers is equal to 18. Okay. And regarding 9, 22, 26. If my answer instead of 25, if it is 26, then the correct choice will be B. Okay, let me see if I have missed any outcome or not. So if the sum of the numbers showing up is 9, we can have, if I consider 1 showing up on the first die, then the sum of the numbers showing up on the second and third die has to be 8. So we have 1 2 8, 1 2 6, we have 1 6 2, okay, we have 1 3 5, and we have, oh sorry, I missed a 1 hyphen 4 minus 4. 1 minus 4 will also be outcome where the sum of the numbers on the 3 die is equal to 9. So then small m will be 26, and now I will have the probability of E will be 26 by 216, which is 13 by 108. 13 by 108. So the correct choice is B. B is the correct choice. Now I really solved this problem using a very lengthy way of finding out all the possible outcomes. If you know a better way and quicker way, please feel free to share it in the comment section. I will highly appreciate that. Okay, let's see the next problem, the last problem. A number x is randomly selected from the set 1, 2, 5, 6. Another number y is randomly selected from the set 3, 4, 7. Find the probability that x's cube will be less than y square. So the number x can be any number from 1 to 5, 6. So first of all, what will be the small n? In how many ways we can select the two numbers x and y? It will be the number x can be selected in there are four possible. The number x can have four values. We can select we can select a. There are four possible values of x because the set 1, 2, 5, 6 has four numbers. So 4 multiplied by 3, that is 12, will be the total number of ways in which we can select x and y. So if you list down, possible outcomes will be something like, if the value of x is 1, then I can select the value of y to be 3. I can select y to be 4 and y to be 7. Again, I can select x to be 2. So 2, 3, 2, 4, 2, 7. Again, a 5, 3, 5, 4, 5, 7. And finally 6, 3, 6, 4 and 6, 7. So these are all the possible outcomes. That is, these are all the possible outcomes of randomly selecting a value x from the first set and randomly selecting a number y from the second set. Okay. Now, in this set of all the possible outcomes, I have to choose only those outcomes. We have to find only those outcomes where x's cube is less than y square. X's cube is less than y square, where the value of x is coming from 1, 2, 5, 6. Okay. So if I consider event E to be that x's cube is less than y square, then what are the outcomes which are favorable to the event E? Can it be 1, 3? Yes, it can be 1, 3. It can be 1, 3 because 1, 3, this outcome is favorable to the event E because we know that 1 cube is obviously less than 3 square. Can it be 1, 4? Yes, it will be 1, 4. We can choose 1, 4 because 1 cube is less than 4 square. Can it be? Obviously, it will also be 1, 7. The outcome 1, 7, that is x is 1 and y is 7, will also be favorable to the event E because 1 cube is less than 7 square. Can it be 2, 3? Yes, it can be 2, 3 because 2 cube is less than 3 square. 2 cube is also less than 3 square. Okay, can it be 2, 4? Yes, it can be 2, 4. It can be 2, 4 because 2 cube is less than 4 square. Okay. Can it be 2, 7? Yes, it can be 2, 7 because 2 cube is less than 7 square. Can it be 5, 3? Can it be 5, 3? 5 square, 5 cube is 125 and 3 square is 9. Obviously, 5 3, 5 cube is greater than 3 square. So 5 3, the outcome 5 3 is not favorable to the event E. So this will not be there. Because 5 cube is greater than 3 square. Can we have 5 4? 5 cube is again greater than 4 square. So we cannot have 5 4. Can we have 5 7? No, we cannot have 5 7 because 5 cube will again be greater than 7 square. Can we have so definitely you can see that 6 3, 6 4, 6 7 will also be not favorable to the event T. 6 3, 6 cube is greater than 3 square. So this 6 3 will not be there, is not favorable to event T. 6 4, 6 cube is greater than 4 square. And finally 6 7, 6 cube is greater than 7 square. So 6 7, the outcome 6 7 is also not favorable to the event T. So the number of favorable cases and the number of outcomes which are favorable to the event E are 1 3, 1 4, 1 7, 2 3, 2 4, 2 7. So there are 6. M is 6. So then the probability of the event E will be equal to M by N, which is 6 by 12, which is equal to half. So half is the probability of the event that the number X is the probability that when a number X is randomly selected from the first set and a number Y is selected from the second set, then X cube will be less than Y square. The probability is half. Probability is half. So the correct choice is A. So with this, it brings to an end in solving 5 multiple choice questions which are based on the possible outcomes of a random experiment, the favorable, the figure it how to find the favorable cases of a given event based on the random experiment, and finally how to find the probability of some event. These questions were based on the concepts that I discussed in part 12, 13 and 14. So if this video was beneficial, then please like it, share it with your friends, and once again please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. In the next couple of videos, I will try to solve the problems. I will try to solve all the problems that are given as exercise in the textbook and as well as the MCQ practice questions book. So please stay tuned for more problem solving sessions on the chapter of probability. I am ending the video here. Thanks for watching, and until the next video, take care and bye.